So I've been tweaking a Desmos simulation I made for collisions, and it's a really neat way to look at collisions that are either inelastic, elastic, or somewhere in between. There's a decoder ring I put an image I embedded in it to help you make sense of it, but I'll explain it real quick. You can look at, well, first of all, you can change the parameters. I'll put this video link here. U is 1 for perfectly elastic collision, 0 for perfectly inelastic collision, and everywhere else somewhere in between. That's coefficient of restitution. You have to pick a mass for M1. So in this simulation, red is 1, blue is object 2. And we're going to look at what happens when it's a perfectly elastic collision from the lab frame. And then what if it's a partially elastic collision when this U is something other than 1. And with dotted lines, you'll see you can actually turn on, just toggle these folders on and off to view it from the center of mass frame, or partially elastic or perfectly elastic. For right now, I have the U set to 1, so perfectly elastic and partially, I should change that spelling, will be exactly the same. So you look over here, remember, orange is 1, blue is 2. These two represent the initial velocities. Ignore the -4 and the -2. I just had to get it on the screen. So let's say you have, we'll start with the classic case, like a billiard ball coming in or something, and hitting another billiard ball that's the same mass and at rest. So if the red, or rather the orange, has an initial velocity of 3, and the blue is kind of like a ball just sitting there, it's got the same mass but an initial speed 0, after the collision, the velocities basically switch. So where the blue is supposed to wind up at 3 and the orange is supposed to wind up at 0. It's a classic case here. So when you look at the after, now you can see both a graph and for a specific value. So graphically, this is M2 getting bigger, and these are the velocities. Again, orange here is going to be the velocity 1 after. Blue is going to be the velocity 2 after. This purple thing allows us to sort of inspect. So let's pull it. We used a mass of 2, so I'm going to inspect right at when the value here is 2, and you can see the blue one now has a velocity of +3, and the orange one has a velocity of 0, just like we expected. The green here is the velocity of the center of mass. Now, just to show you, if you wanted to view this from the center of mass frame, what you would see is it looks like both balls are moving towards the center of mass at the same but opposite speed, which will be half, which is 1.5 meters per second here. Another common question is, well, what if you had like a giant elastic tractor trailer hit a small elastic bug or something like that? So let's say we make this mass really big. Let's make it, I don't know, 10,000 or something. You can see what happens is the lines flatten out because there's almost no change to the truck, and there's a big change to the bug. So right now we're still in the center of mass frame. So you can see the big tractor trailer is moving at the same as the center of mass velocity. Let's switch to the perfectly elastic lab frame. And here, this is a classic result. If the elastic bug was at rest beforehand, after the collision, it always has a speed that's twice the elastic truck speed afterwards. And the truck speed, of course, is basically unaffected and moves at the same as the center of mass velocity. If they were coming together at exactly the same speed but opposite direction, so if they have a head-on collision, that's another classic case, the elastic bug always moves away at 3 times the velocity of the elastic truck. Let me show you just for fun if you wanted to have a partially elastic collision. So that's a perfectly elastic collision. So if I make it partial, now right now I have to go change the U value. I don't want the center of mass frame, I want the lab frame. Just go up here to the U parameter and make that, if it was a perfectly inelastic collision, they would both move at the center of mass velocity. Everywhere else it's somewhere in between, and it shifts until it's 1. It's at the same as for a perfectly elastic collision, because it is. Let's go back to something a little more comparable. So if you have 2 objects that are on the order of the same mass, so if you go back to 2 here, again, you can sort of inspect. Now visually you can see as the mass increases what happens to the velocity. Like as mass 2 increases, the velocity 2 approaches the center of mass velocity, because as mass 2 is most of the mass of the system, you're already moving at the center of mass velocity. And if mass 2 gets really, really big, you wind up with the same scenario we had a second ago, where now the first object has a velocity of 3 times the initial velocity of the second object. Again, you can move this mass, like let's say you're trying to generate problems for students or just for practice or something. Dragging this slider bar changes mass 2, and this will tell you the velocity 1 and 2 after the collision, and of course the center of mass velocity without having to go look it up. It's sometimes fun to look at it from the lab frame, which is really how this whole simulation works anyway. That's what the little dots are in the center of mass frame. And these dashes are with energy loss in the lab frame. So if I turn off the center of mass frame for a minute, and I turn back on the perfectly elastic, right now U is 1, so they're exactly the same, but you can visualize what happens as U goes to 0. They both end up at the center of mass velocity. They're stuck together. As U goes to 1, you get the result from that sort of special formula you learned. So for students, I don't know that it's critical that they memorize those special formulas, but it is kind of neat to look at the relationship between the relative masses for perfectly elastic collision and the results that you get. This kind of lets you experience that. Again, you can change mass 1 with this. You can inspect for mass 2 with this, and you can change V1 and V2 before the collision with this. If you're not sure what any of these things mean, they're over here. So I thought I'd